Hello everybody and welcome to today's lesson. Today is the second lesson on graphing rational functions, which we have started in the last class. And today our objectives will be we will graph rational functions and we will determine function characteristics. So remember, a rational function is a function that has a polynomial in the numerator, and let's call this p of x, and a polynomial in the denominator, let's call that one q of x. Then our polynomial p of x has a degree, and remember, degree is the exponent of the highest term in the polynomial, and let's call that degree m. And the other polynomial q of x also has a degree, and let's call this degree n. If that is the case, then we can have three different possibilities. M can be less than n, m can be equal to n, and m can be greater than n. And in today's class, we will explore how those three different cases influence the graph of our functions. Let's start with the case m is less than n. If that is the case, a horizontal asymptote will be at y is equal to 0, and it's really at y is equal to k, as you remember from the last class, but for the purpose of today's lesson, k will always be 0, and therefore the horizontal asymptote will always be where y is equal to 0. Our vertical asymptote is, of course, where our denominator turns to 0, and our x-intercept is where our numerator turns to 0. And if we think about our horizontal asymptote being at 0, let's look at our function and see how that makes sense. If the numbers for x get larger and larger and larger, then our denominator with an x squared in here will get larger much faster than the numerator. And eventually it will be so large that the numerator will really not matter anymore, and we will get closer and closer to 0. Then let's go ahead and find our function characteristics and start graphing our graph. But before we do that, let's see if anything in our rational function can be factored. The numerator cannot, but our denominator is our well-known difference of perfect squares. So this is x minus 4 times x plus 4. And now let's start by finding our horizontal asymptote, which is, as we had discussed, at y is equal to 0. Our vertical asymptote is going to be where the denominator turns to 0. And having a look at our factored form, we see that we actually, in this case, have two vertical asymptotes, because x is not allowed to be positive 4, but it's also not allowed to be negative 4. Those two values are the main restrictions, and they will lead to our vertical asymptotes. Let's look for our x-intercept. So where is our numerator going to turn to 0? Simply where x is equal to 0, right? So that means our x-intercept is at the point 0, 0, or in other words, our origin, and therefore we also have our y-intercept here and don't need to look for that one any further. So let's set up our framework for a graph. The horizontal asymptote is at 0, and our vertical asymptotes are at negative 4 and at positive 4. We have our x-intercept at the origin, as we had said before. And now some of you may say, but Mr. Fieser, if the x-intercept is at 0, we will be crossing the horizontal asymptote. That is indeed true, and it's okay to cross the horizontal asymptote in this central part. Remember, the horizontal asymptotes really give us information about the end behavior. In other words, where the x's get really small and where the x's get really large. In the central part, it is not that important, and it can indeed happen that our graph crosses the horizontal asymptote in that area. It can, however, never cross the vertical asymptotes. Remember, our vertical asymptotes really tell us about domain restrictions. The x values do not exist at that point. Therefore, we can never plot a point that goes across the vertical asymptotes. This is not really all that much information yet to go ahead and graph our function. Therefore, we need to plug in a few more numbers for x and find a few more points. I'm going to choose some which are to the left or to the right of our x-intercept. In other words, -1 and +1. And I'm going to also choose a value which is to the left of our left vertical asymptote, -5, and another one to the right of our right vertical asymptote, +5. Here they are. F of -1 is -1 over -1 squared minus 16. In other words, -1 over -15, which makes it +1/15. F of +1 made the numerator positive, so therefore our entire fraction therefore turns negative, -1/15. F of -5 is -5 over -5 squared, in other words 25, minus 16, or -5 over 9. And f of 5 is +5 over 9. So let's go and plot these points. -1, we go the tiniest little bit up from our x-axis. And at +1, we go the tiniest little bit down from the x-axis. At -5, we go down 5/9, which is a little more than half. And at +5, we go up 5/9, a little bit more than half. So those are our points. We know that from there, our graph will approach our asymptotes. We also know that the graph will, particularly in this middle part, it will not cross the x-axis again, other than at that one x-intercept we found. We cannot cross the x-axis again with our graph if that was not an x-intercept that we also found algebraically. So we can go ahead and graph our function now, coming from the vertical asymptote and going back, approaching the other vertical asymptote. And our left part comes from the horizontal asymptote, approaches the vertical asymptote, doesn't cross it. Remember, that's not possible. And our right part looks like this. This is what this should look like. Now let's check with our calculator. Put your function into the y is equal to, and make sure that you always put parentheses around your denominator. Otherwise, your division will only take part of the denominator. And let's look at our graph. And that looks very much like what we have. And we can see our vertical asymptotes at -4 and +4. All right, let's move on to the next example. This is another example of where m is less than n, the degree of the numerator is less than the degree of the denominator. Let's look at our function, and our denominator cannot be factored, so we are good to start. All right then, our horizontal asymptote, as we said, is at y is equal to 0. Our vertical asymptote is going to be where our denominator turns to 0. X squared, no matter what we put in for x, we will get a positive number when we square it, and then we add 1 to it. In other words, we can never get to 0. If we can never get to 0 in the denominator, then we have no vertical asymptote. The answer is none. And let's look at our x-intercept. When does our numerator go to 0? Well, the numerator is 4, and 4 will never be 0. So we also have no x-intercept. Then let's look for y-intercept at least. The y-intercept is where x is equal to 0, so f of 0 will be, this turns to 0, and we will have 4 over 1, or just simply 4. 0 and 4 are the coordinates. And now we can go and put everything down that we have so far. Our horizontal asymptote at y is equal to 0. No vertical asymptotes, no x-intercepts, and a y-intercept at positive 4. This is great, but really not very much information to know how we should graph our function. We do know that our graph will approach the horizontal asymptote both towards negative infinity as well as towards positive infinity, but we want to know how fast that's going to happen, and therefore I will pick two numbers, -1, one step to the left of our y-intercept, and +1, and find our y values for those. Ta-da! F of -1 is equal to 4 over -1 squared, which is 1 plus 1. So 4 over 2, or in other words, 2. And f of 1 is also 2. So we get these 2 points, and we can now go ahead and graph our function, which approaches the horizontal asymptote towards negative infinity and also approaches it towards positive infinity. Let's look what our calculator says. Here's our function, and here's our graph. Looking good. Then let's move on to our next case when m is equal to n. If m is equal to n, the horizontal asymptote can be found by dividing the leading coefficients. Remember, we already talked about that in the last class, and it's simply because if our x's get really, really large, then whatever we are adding or subtracting in the back doesn't really make any difference anymore. And if the x's are the same values, we could even cancel them out. So what really matters is the coefficient of those two, and those are the ones we're going to divide to find our horizontal asymptote. Vertical asymptote will still be where our denominator is 0, and our x-intercepts will also still be where our numerators are 0. And before we even get started, we are going to see if we can factor anything in this function. The numerator cannot be factored, but our denominator is yet again a difference of perfect squares. By now, I hope I have driven the point home. Really, really make sure that you always keep an eye out for that. It comes up a lot. And it gets factored, of course, into x minus 2 times x plus 2. And now we're ready to start. Let's find our horizontal asymptote. I had already marked the coefficients into our function, which are 1 and 1. So 1 divided by 1 is 1. Vertical asymptotes, we again have 2, because x is not allowed to be positive 2, and x is also not allowed to be negative 2. What do we have in terms of x-intercept? The x-intercept will be where the numerator is 0, and that will happen if x is 0. And again, we have an x-intercept that's also a y-intercept, and it's at the origin. Let's mark everything we have in our coordinate plane and see where we are. Horizontal asymptote is at +1, and 2 vertical asymptotes, one at -2 and one at +2, and an x-intercept at 0 and one x-intercept only. Again, we need a little bit more information to be able to graph, so I'm going to find points one step to the left and one step to the right of our x-intercept. In other words, at -1 and +1. And I'm also going to find the points at -3 and at +3. And here they are. F of -1 is -1 squared over -1 squared minus 4. 1 over 1 minus 4, or 1 over -3, which is -1/3. And f of 1 is also -1/3 because both x terms in the numerator as well as in the denominator get squared. So it doesn't really matter whether I plug in a negative or positive integer. And so f of -3 is positive 9/5, and so is f of +3. Now I got some points to plot. So at -1, I have -1/3, so less than half down. At +1, I have -1/3 again, putting the point at the same y coordinate. And at -3, I got 9/5, which is just a little less than 2 positive. And at +3, I also got positive 9/5, which is going to be here. So that's enough information for us to graph our function. And again, our ends always approach our vertical and horizontal asymptotes. And the middle part particularly will never cross the x-axis again. It only touches it once, and if we don't find another x-intercept algebraically, then we most certainly don't have one graphically either. And here is our function. So much for this. Now go ahead and watch the second part of this tutorial.